talk about sketching polynomials in factored form. So let's start off with something like, let's start off with a linear equation, actually. Let's do y equals x minus 1. So the 0 of this equation, the number that we have to substitute in for x to make y equal to 0 is 1. So 1 minus 1 is 0. So that will look like this. I'll have a 0 right there. And it's a line with positive slope, so it's going up like this. Now let's consider y equals x minus 1 times, why don't we say x plus 1. So now we've got zeros 1 and negative 1. So let's plot those. We've got negative 1 right here and 1 right here. And, well, we know that it's going up because x times x is x squared. That's positive, so it's a smiling parabola. Eventually we'll have to figure out how to know that without actually multiplying everything out, though. And don't worry, we will. Now how about y equals x minus 1, x plus 1, x plus 2. So now the zeros are 1, negative 1, and negative 2. So we'll plot those. Negative 2, negative 1, and 1. We know, again, that the x cubed is positive, so it's got to be going up this way and down this way. So it's got to be going like this. Now let's try a harder one. Let's do y equals x minus 1 squared times x plus 1 times x plus 2. So that means we've got zeros at 1, negative 1, and negative 2. And we want, well, if we look at the first term, this is x squared times x times x, this is x to the 4th. But how does that, does it look like 1, 2, 3 and then up? Or does it go like this? Or how can we tell? Well, actually, all we need to do is look at each 0. Look at the power on each 0. So starting, actually, just looking back, all these zeros, all these factors had power 1. This is to the first power. This is to the first power, first power, first power, first power, and it always crosses over the line when it has a power 1. But whenever we have a power 2 factor, then it doubles back on itself. In general, if we've got odd factors, then it crosses over. If we've got even factors, even exponents of the factors, then it doubles back. So this negative 1 right here is going to either look like this or like this. And we can actually determine that just because we know the end behavior has to be going up this way and up this way. So let's try tracing it out. This 0 goes through because negative 2 is the first power. It's an odd power, so it crosses through. And then when it comes back here, it's coming from this side, so it has to go down here. And then come back through this 0. So we can erase the indicators we made up here, just in case. And that would be the graph of our function. Let's try another one. Oh, you know what? Just to solidify this concept, let's actually let's just do one more pre-example. Y equals x plus 1 squared. Well, that's a parabola, right? And it doubles over at -1, goes like this. Versus we're like y equals x plus 1 would just be a line through -1. Same thing. This is doubling over. This is crossing over. Okay, so let's do another. Let's do y equals x plus 1 to the third, x minus 1 squared, x plus 2, x minus 2, something like that. Okay, so this 0 is -1, this 0 is 1, this 0 is -2, this 0 is 2. So let's make those points on our graph. -1 is here, 1 is here, 2, and -2. So we've got a 0 at each of these. Now let's look at each of the factors. Well, this x plus 1 to the third, this is an odd factor. So that means that at -1, at the 0 there, it's going through. So it's either going through like this or like this. At +1, this is an even factor. It has an even exponent. So it's either doubling back like this or like this. I see how this can be kind of hard to see because they both look like x's. Why don't we introduce some color so that we can see this better? So this is either going through like this, this is either doubling back like this, or maybe it is going through like that, or maybe it's doubling back like that. And then, okay, for -2, this is an even factor. Or no, sorry, it's an odd factor because that's a 1 exponent. So this is going through. It's going straight through. So it's either going like this or like this. And same thing for +2, that's an odd factor, so it's going straight through. So now let's draw our end behavior and figure out what's happening here. So our end behavior is, well, this is an x to the third, this is an x squared. I'm going to write them here, x third, x squared, an x, and an x. So our highest degree term is an x to the 3, 4, 5, 6, 7, x to the 7th, and that would be increasing this way and decreasing that way. So now let's go and draw through. So here we're approaching from the bottom, so we have to follow this way. Now we're approaching from the top, so we have to follow this way. Now we are approaching from the bottom, so we have to follow this way. And now we're approaching from the bottom again, so we have to follow this way. So yeah, now we have a pretty decent image of what is going on.